Okay, fine. Let's try to answer these questions, friends. When do we resort to linear regression? When do we resort to linear regression? When do we select linear regression algorithm? What kind of problems we can solve with linear regression? When the output variable or the dependent variable y is continuous, irrespective of the type of input variables. It could be continuous as well as discrete. So we can go for linear regression algorithm. Logistic regression is used to predict the output, which is y is discrete, right? So what is the logistic regression curve called as? Sigmoid curve or S curve in short. In logistic regression, the predicted output will be the output, the model returns us what exactly the output is. They are the probabilities. They are not the discrete values. Based on the probabilities, we need to convert them to the output values that we are predicting. Clear? What is the function used to calculate probability in logistic regression? Probability can be calculated by using the formula e power y by 1 plus e power y. Or it can also be written as 1 by 1 plus e power minus 1. Both are same. Correct? So what are the assumptions of logistic regression? What is the first assumption? The output has to be clearly a certain class out of the possible classes. It cannot be more than one classes, or it cannot be somewhere middle in between the classes. It has to be clearly either the class 1 or class 2. Depends on the number of classes that you have in your output variable, right? And what are the other assumptions that we discussed about logistic regression? The output value should be statistically independent. Means it has to be mutually exclusive from other values and collectively exhaustive. What do we mean by collectively exhaustive? When you consider all the possible output values, it should map to the output variable, the possible values of your output variable, right? What is forward feature selection? Where did we discuss about this? What is forward feature selection? Come on, guys. We discussed this in the first session, and we discussed again in between the basic strategy. What are we talking about here? We're talking about feature selection. What are features? What are features in your data? The variables or the dimensions or the columns. You can also call them as features. So when do we go for forward feature selection? First of all, what technique is this? This part of feature engineering. Means if you have thrown a huge set of data, huge dimensional data, you cannot go ahead considering all those variables for model building. As part of VDA, you need to understand which are the most important features towards the output variable prediction. And you would need to confine only to those important features to build the model. So we discussed about 3 different techniques as part of feature engineering. Forward feature selection, backward feature elimination technique, and stepwise selection. In multiple linear regression, we discussed about forward feature selection. When we compared multiple R-squared value and adjusted R-squared value. So initially we consider very few features for building the model, and slowly we keep adding a variable at a time and see how it's going to impact on the output variable predictions. So which measure do we take into consideration in case we decided to apply linear regression? Which measure do we take into consideration for determining the importance of the new variable that we added onto the model? Adjusted R-square value, right? If the newly added variable is completely irrelevant towards the output prediction Y, then how does adjusted R-squared behave? It starts moving down, starts decreasing. That means adjusted R-squared starts penalizing the model when you add a variable which is not relevant for the output prediction. So looks like not even revising what we discussed. Don't lose a touch. Okay, just keep the momentum going. At least devote 2 hours a day. Only then it will be helpful. Yeah. The default cutoff value used in logistic regression. What is the default cutoff value we used? 0.5. The output or the predicted values of your logistic regression are the probabilities, right? How do you determine the output values based on these probabilities? So you come out with a cutoff based on your subject matter expertise, and whichever the records are having a probability value more than the cutoff would be treated as one class. If they're less than that cutoff value, would be treated as the other class. And this is how you are going to extract the output values that are irrelevant to the actual output variable. Clear? What are various types of logistic regression we discussed? Types of logistic regression. Simple and multiple. Any further segregation that we discussed? Binomial logistic regression. When we are dealing with an output variable which has two classes, we can go for binomial logistic regression. What are the other types? Multinomial logistic regression. If the output variable has got more than two categories, you can go for multinomial logistic regression. And we also discussed about ordinal logistic regression. When the output variable is of count in nature, so you can go for ordinal logistic regression. Right? Yes. So what does odds mean? Odds is nothing but the ratio between probability of an event to occur versus probability of the event not to occur. Odds ratio is nothing but if the probability of an event to occur is P, the probability of that event not to occur is obviously 1 minus P. So the ratio between probability of an event to occur versus not occurring is nothing but odds ratio. What is log of odds? If you apply log on both sides, what do you call that function as? Logit function, right? It's not line function, Praveen. It's logit function. Logit. Okay. Okay, fine. So let's start with multinomial logistic regression now. Various types of logistic regression. If your output variable has got only two classes, which are of discrete in nature, then you can go for binomial logistic regression. If your output variable has got more than two classes or more than two categories, then you can go for multinomial logistic regression. If Y has got count data like 1, 2, 3, 4, 5, to predict that, you need to go for ordinal logistic regression. Am I clear, Praveen? Okay. I'll get it. We'll take care. Don't worry. Rita, you can go through the recordings, or else you can get in touch with the sales team. They'll be able to upload to your LMS. Okay. So what is the link function in logistic regression? What is the link function? Link function is nothing but the logic function. Okay, log of odds. So what is the R function to build logistic regression model? What is the function we have used in R to build logistic regression? GLM, right? So for linear regression, we have used LM. For logistic regression, that is GLM, generalized linear model. What are the arguments we pass in for GLM? Okay. So GLM of y tilde all input variables. If it is a single variable, only x. Otherwise, x1 plus x2 plus x3 and so on. Y tilde x and then data equal to, so which data frame you want to apply this logistic regression on. Okay. And what else? Family. So this family is what where you're going to decide upon which type of logistic regression you would like to apply. Is it binomial or multinomial? Yeah. So what is the factor in R? What is a factor in R? Is it a data type? Describe the levels. Levels nothing but the classes. All the categorical variables or the discrete variables have to be recorded as the factor data type in R. And that's the data type designated for reading the categorical data. Okay. What is null deviance and residual deviance? What is null deviance? Online folks? Anybody can answer? What is null deviance in logistic regression? It's the error term that's built using only the intercept value. If you consider only the intercept value in your logistic regression equation, null deviance represents the error term by considering only the intercept value. How about residual deviance? Along with the intercept value, you consider all input variables the error term that is calculated by considering all input variables in your model would be calculated as residual deviance. So which one should be higher? Which one should be lower? Residual deviance should be lesser than null deviance. So that effectively shows by considering or by adding the input variables, null deviance should be higher. So if the residual deviance is lesser than null deviance, that shows the importance of the variable that you are adding onto the model. So by adding the variables, the error term is reducing, which is very much expected, right? What is the AIC value? What is the full form of AIC? Archaic information criteria. Why do we use this value for? You're almost right. Exactly. When you have multiple models, to pick up the model that is performing to a better extent can be determined by looking at the AIC values. So you have to compare the AIC values across the models. Whichever the model is giving the least AIC value should be considered as the best performing model. Clear? We already looked at this question. So what is table function? Why do we use the table function for in R? Table function. To form a table, which table? Estimated coefficients. No, Praveen. Why do we use the table function? To form a table, that is the correct answer, but which table, that's what I want to be precise. But we have confusion matrix, right? Why do we use this table? Do we have confusion matrix in R? The function called confusion matrix in R? We have it in Python. Okay. So to build the cross tabulation function, among the categories, number of categories, it could be 2 by 2 matrix. Let's say if your output variable is 2 class. So these are your actual values. And these are your predicted values. How do you measure the accuracy of an output variable which is categorical in nature? Only through the confusion matrix, right? If you have only 2 categories, you can straight away draw the confusion matrix. But if you have more number of categories in your output variable, so that's where we go for this table function to develop the cross tabulation. It could be 3 by 3, 5 by 5, 10 by 10, any number of, right? How do we measure accuracy of logistic regression model? But that's not the accuracy, right? It just tells us which model is performing better. But if you have only one model, if I ask you, how accurate is your model? How do you measure that? Online folks, if I have a model built using logistic regression model, if I ask you what is the accuracy of your model, how can you tell me? Which measure do you make use of? Why do we use the ROC for? Does it tell the accuracy of the model? We use ROC to determine the cutoff value. Not ROC, Hardik. By looking at ROC, you'll not be able to understand the accuracy of the model. Can we calculate the accuracy by using confusion matrix? How can you calculate? What is the formula? What are the 4 quadrants that you will have in confusion matrix? True positive, true negative, false positive, false negative. Provided you have taken the predicted values on the columns and actual values on the rows. Correct? So what is the formula for calculating the accuracy? True positive plus true negative. Sum of correct decisions divided by total number of decisions. Right? True positive plus true negative. Divided by all quadrants, all 4 quadrants. True positive plus false positive plus false negative plus true negative. Yeah. What is ROC curve? The plot that you draw between true positive rate versus false positive rate. That means sensitivity versus 1 minus specificity. Nothing but ROC curve. Receiver operating characteristic curve. Right? It tells us how accurate is your model in terms of identifying or predicting the true cases, the positive cases as true. Right? So what does sensitivity mean? What is sensitivity? True sensitivity is also called as true positive rate or hit rate or recall. What exactly it tells us? What is the formula for sensitivity? True positive divided by true positive plus false negative. Correct? Out of all actual cases, actual positive cases, how many you are correctly identifying as positive? That's what sensitivity tells us. Clear? Now, just give me a second, friends. Okay, fine. Now let's look at multinomial logistic regression. When do we go for multinomial logistic regression? When Y is categorical in nature, it has got more than two categories. That's when you can go for multinomial logistic regression to predict the value of Y. Y is nothing but the dependent variable or the output variable. Just loading these packages, mlogic. Data of mode. Mode is nothing but mode is nothing but transportation mode. Just pay attention, friends. Let's try to understand this case study. So we were given the cost of the car. If you hire a taxi, what would be the cost of it? And if you go for a pool of car, you know carpool, right? 2 or 3 people together would travel, and the cost of it. And cost of bus. If you pick up a bus, what would be the cost associated to reach from a particular destination, from a place to other place? And cost of train. And similarly, the time it is taking. With each of these transportation mode. So given the cost and time associated with each of these transportation modes, we were given the historical data with respect to which was the choice for that particular passenger. Given these figures, what exactly a particular passenger has chosen. Now, we need to build a model to predict how many transportation options we have here. 4 options. One is car, carpool, bus, and train. Given the values of cost and time, we need to develop a model to predict which would be the most optimal transportation mode. Clear? So how many classes we have in this output variable? There's the overall number of classes we have in the output variable, choice. 4, right? So number of, it's a categorical data. It's more than 2 categories. So that's why we need to resort to multinomial logistic regression. Let's see how many values we have in this output variable choice. So we have all 4 options: car, carpool, bus, rail, and which is being highly used? Car. And next highest, train. Right? The relevant proportions are given. Now, to build a multinomial model, you can go for, I'm attaching this data set, attach mode. Function is multinorm. You can do it in 2 ways. One is by using the function directly multinorm, or you can still make use of GLM, but pass on the family as multinomial. Okay. Output variable is choice, tilde, the all input variables, cost and time figures. Right? Since I attach this data set, I don't need to pass in the data argument. Not find multinorm function. Come on. Yeah. Package was not enabled. Built a multinomial logistic regression. We look at the weights. What do you think these iterations are? Guys, any idea what do you think these iterations are? What are these weights? Do we have 27 variables in our data? No, right? Hardly 8 input variables and 1 output variable. Overall 9 variables we have. Sorry? 4 into? How much it will be? Then how come it is 27? Let's look at the summary of it. So we would need to optimally select the right choice based on the cost given to each of the transportation mode. Now, by building this multinomial logistic regression, what it does is it makes one of the option as the baseline. It starts comparing the other 3 options with that baseline mode of transport. So in this case, we have carpool, bus, rail. What is the other option that is missing? Car is missing, right? So that means it has made car as a baseline option and it starts comparing the other 3 options with it. And in relevant to the baseline option selected, it's going to calculate the coefficient values. These are the standard errors. Similarly, the residual deviance is given and the ASC value is given.